Hi guys, this is Mr. Mellor. This is a video to help you with lab number 6. This is our forces and motion PhET simulation lab. We're looking at types of friction, so it's static friction and kinetic friction, and also we're looking at free body diagrams. So to help you with this video, you can go ahead and follow along. We're just going to work through the lab together. Okay, so first step is to click on the lab simulation link. This is also in Microsoft Teams for you, but you can go ahead and click here. So I've already done that. It's going to take us to this screen right here. All right, after we've done that, we're going to go to, step 2, we've appeared at that screen. Wonderful. Cha-ching. All right, step 3, we have pull the applied force slider bar over so it reads approximately 300 newtons. All right, so we're going to go ahead and do that. And then before we do that, though, let's look at the guiding questions. What happens to the force of friction as the applied force increases? So the force of friction is represented by this FF right here, force of friction, and then FA is applied force, okay? And so when we move the slider bar, we're going to increase the applied force, and what we're going to see, well, we'll see a couple of different things, but just pay attention to this arrow, FF, as we adjust the slider bar. And we're going to see what happens. Okay, and then question 2, what type of friction is represented in the situation in question 1? Explain how you know. Look at the vocabulary words if you get stuck. All right, so let's go ahead and go to the simulation. We have our step is to pull the slider bar until it's approximately 300 newtons. Okay, so we're going to go ahead and pull that slider bar. We see that we have the FF arrow is increasing, the FA is increasing. FA is applied force. That means applied, literally you apply a force, you push. So our mannequin is pushing on our box, and we said we're going to go ahead and go to 300 newtons. Okay, so nothing is happening except for the fact that the force applied is getting bigger, and the force of friction is also getting bigger. But notice one thing. They are pointing in opposite directions. So remember, friction always opposes motion. But then also notice that the applied force arrow is the same length as the force of friction arrow. And so that tells us that the net force horizontally, because those are both acting horizontally, must be 0. And so our object doesn't start to accelerate, and it's already at rest. And if it's already at rest, meaning not moving, and it has no acceleration, then it's not going to start moving. And so what we have up until this point, we can see that the applied force is being counteracted by and negated by, canceled out by, the force of friction. And so the question is, we have 2 different types of friction. What type of friction is this? So we're going to go ahead and I'm just going to pause it. We'll type in 300 newtons with it paused. Okay, and then we see we have the force of FF here, force of friction, FA here, that's our applied push. And we have a couple of other forces, we'll discuss those in a minute. But our first question is, what happens to the force of friction as the applied force increases? Well, what we see is that the force of friction increases to cancel out the applied force. Okay, and so we saw that by seeing that the arrow changed length. That meant there was no acceleration, okay? And so no acceleration means that because our object is already at rest, no acceleration means it's not going to change its speed, which means because the force of friction is increasing to match the force applied, it's going to cancel. There'll be no net horizontal force, and you're going to end up with therefore no acceleration. And so there was no acceleration, meaning the box does not start to move. But what we saw overall is the force of friction increases to cancel out the applied force. All right, what type of friction is represented in the situation in question 1? Explain how you know. Look at the vocabulary words if you get stuck. All right, well, let's go look at the vocabulary words because that's a good hint. Okay, so we have static friction is the type of friction that keeps objects at rest. Okay, so our example is when a person is trying to move a stationary object, static friction keeps it in place. Static friction opposes the direction of motion. All right, then we also have kinetic friction. Kinetic friction is the frictional force that acts between 2 moving surfaces. Well, did we have two moving surfaces in this case? Is our object moving currently? Like our little figure is pushing really hard. He's trying to make progress, but what we're seeing is that there's no net force, and so the object isn't moving, and so we're still in static friction. Okay, so static friction is 100% the type of friction we have here. And so we know that it is static friction because, well, we know it's static friction because there's no movement. Okay, and so kinetic friction, which is our second type of friction, is when there is movement. All right, so what we're going to do, step 4. So again, please don't write my answers word for word, but put in your own words. I have left part of it blank so that you can answer it yourself. But step 4, we're going to move on. So step 4, slide the applied force slider until the box starts to move. Okay, and so when the box starts to move, we know that there must be a net force pointing in the direction of motion, net force to the right. And so this must come when the force of friction is no longer equal to the force applied. Okay, and so there's going to be some sort of transition there. We're going to talk about that. Make sure that the sum of forces box is checked in the menu to the right. All right, so we have the sum of forces box. It's right here. We're going to go ahead and check that. All right, and then we're going to just slide this bar until, so we're going to keep moving it until the box starts to move. And so when does it start to move? Keep an eye on this applied force bar. See that our friction is still increasing with the applied force, or push. Okay, 491, interesting. Okay, so at about 491, the object starts to move. So let's do a playback so we can see that at the very end. Oops. All right, work with the simulation. Go ahead and play it. We're going to go to very slow. Okay, well, what we saw was when we get to 400, it was approximately 492, 91 newtons, we had the object started to move. And so we have, what was the value of the applied force when the object started to move? 492. What was the value of the frictional force at this moment? All right, let's go ahead and reset so we can take a look at that one more time. All right, how did we determine that? Well, remember that the force of friction is always, in this case, before the object's moving, the force of friction is equal to the applied force. You can see that they're both increasing. They're both the same length. They're pointing in opposite directions. Okay, and so when it starts to move, 492, you could see that the force of friction, right before it started to move, the force of friction was equal to the applied force, but then as soon as it started to move, the force of friction was less. Okay, let's do it one more time to show it. All right, so static friction is the same as the applied force. Static friction is the same as the applied force. Static friction is the same as the applied force. Yep. Okay, and we are getting to our threshold. Let's keep an eye out. They look the same. They're still the same. Still the same. Now it's suddenly less. Okay, so after it meets the threshold and our object starts moving, the friction drops off dramatically. And so what's going on there? Well, 492 newtons for question 3 is the value of friction at the threshold. This is our maximum static friction, okay? So this is static friction, and when we start to move, we go to kinetic friction. All right, so how does the value of the frictional force before the object starts moving compare to the frictional force after this object starts moving? Which one is static friction? Which one is kinetic friction? Okay, so we saw, and let's do it one more time. We saw that the force right now, so right before we get to the threshold, the static friction is equal to the applied force, but when we get to the